Okay, so we're going to do a very quick problem just to demonstrate the use of the normal distribution. We're continuing from our previous video. And so let's consider the case where we happen to have all the condo prices in Halifax. And we know that the average price of a condo is $120,000, excuse me, dollars. And the standard deviation is $40,000, right? And we're interested in two situations. One, what is the probability of finding a randomly chosen condominium that has a price of $100,000 or less? So $100,000 or less would represent this entire space to the left of this line. And what if I was interested in finding a condominium that had a price tag of $180,000 or more? It would be over here. All right. So what we want to do now is to find the corresponding standard normal, as I mentioned, because we need those Z values to use the table. And so the 100,000 has an equivalent value. We'll call it Z1. And that allows us to find that probability. The other one here, which is the 180,000, has an equivalent Z value. We'll call it Z2. Now remember, the standard normal has a mean of 0, standard deviation of 1. And the beauty of it comes from the fact that its entire area is equal to 1. All right? So we could find those two values, Z1 and Z2, as follows. And remember, what Z is really the distance between the X values and the average expressed in standard deviation. So Z1 would be X1 minus mu over sigma. Well, what is X1 for us? Is the 100,000 minus 120,000 over 40,000, which is the standard deviation. And that turns out to be negative 0.5. You could do the calculation yourself. 20 over 40 is a half. And since 120 is bigger than 100,000, then we have negative 0.5. If I take now Z2, on the other hand, it would be the 180,000 minus 120,000 over 40,000. So that leaves us 60,000 over 40, which is 1.5. And notice this one is positive 1.5. So with these two values now, we could get the probability of a condo being greater than or equal to 180,000, or the probability of it being less than 100,000. So I'll just make some room here and continue. So we now need to look at some tables. Well, I do have some tables already preloaded, so let's take a look at those. So I want the probability of Z1 being less than or equal to negative 0.5. If I go down here, I think I have it down here. This table will give that to me. And I got those tables off the internet, but most of our textbooks actually have those tables. So I'm looking for 0.5. And this is not scrolling. Let's see. And if I did this, would this one scroll? They're not scrolling. Well, let's try this. Because, I see. So my tables are actually cut off. I didn't get the full table in here. But I think I may remember what they are. Let's see. And this is not scrolling either. So let's go back. Actually, I'll show you something here. I could certainly use inside of my program, I could use my web browser. So if I go to www.google.com and I look for normal table, normal is the normal distribution table, then we will get some pictures right here. So let's take a look at this one. If I view that image, here it rolls up. So if we look at negative 0.5, right here, I gotta change the color so that you could see it. So negative 0.5, maybe find something a little darker. Right here, then we will see that the probability is 0.3085. And if we scroll down, let me go back to, so I wanted negative less than or equal to negative 0.5. Well, that turns out to be 0.3085, which means that there's a 30% chance, almost a 31% chance, that I could find a condominium with a value of 100,000 or less. Now I want the other case with a greater than or equal to 1.5, and we could find that by finding the area under the curve. So if I go 1.5, let's see what we get in my diagram right here. I do have 1.5, but what you'll notice is that 1.5 is the area in the bottom end of the tail. But because of the symmetry in that diagram, that area, even though it is for negative 1.5, it's the same area for positive 1.5. So let's take a look at that. What am I talking about? So to get this is 0.0, I believe it was, if I go back again, 0.0668, 0.0668. Let me explain why it's the same thing. So if I look at this diagram, I looked at negative 1.5. Negative 1.5 had 0.0668. But because this diagram is symmetrical, 1.5 over here is exactly the same area, 0.0668. And so that gave me my answer right here. If I was interested in the probability of finding a house less than 180,000, then it would be all of this area right here. I would have to shade all of that. In which case it is just the balance of 1 minus 0.0668, which gives me 0.9332. All right. So there's a 93.32% chance that I could find a house or condo, sorry, with a price tag of $180 or less. Right. So that demonstrates how we use the normal distribution. Just to kind of recap very quickly for you, we said that we had a population, and from the population we could study samples. Right? Population. In this case, we were interested in a population that has a distribution that looks like this. That's a normal distribution, the bell-shaped curve, and then we were interested in finding out probabilities under that curve. To find those probabilities, we use the scaled version called a standard normal. So this is normal. This is standard normal. And we find a corresponding Z value, Z1, Z2, and use the tables to give us the areas that we're looking for. So in our problem, this was, first case was 30.85, and then this area was 0.0668. All right, which basically means that there's a 7% chance that we could find a house of more than $180,000 with more condo, sorry, or a 30% chance of finding a condo less than or equal to $100,000. The probabilities, of course, will depend on the mean and the standard deviation. But that gives us a sense of how we would use the normal distribution. And the normal distribution, we would use it again when we talk about single inventory management models. We can use it in forecasting. We could use it in quality management. All of these areas actually allow us to use the normal distribution quite effectively. Okay? Thank you.